Hi, and welcome to Unit 1, Lesson 3, Primes, Composites, and Factors. In this lesson, I'm going to cover what is a prime number, what is a composite number, how to find factors of a number, how to find prime factorization, and I'm also going to throw in divisibility rules because it comes in handy when you're trying to come up with the prime factors or factors for a number. It's a lot of information. I'm going to go kind of quickly, so if you need to pause the video, by all means do that. You have that power. Let's get started, shall we? First thing we need to do is go over some definitions. I have on the screen right now prime number. A prime number is a number whose only factors are one in itself. Now, I hate when teachers give definitions and inside the definition is a word you might not know. So the word factor you may not know. Let me go through this really quick. In math, a factor is numbers that are multiplied together to give you another number. So if I wanted to know factors of 20, for example, well, 4 times 5 would give me 20, so 4 and 5 are factors. Now, there are more, I realize that, but just so it helps you with this definition. So a prime number, then, is a number whose only factors are 1 and itself, meaning the only way that you can get it through multiplication is by multiplying itself by 1. Perfect example is 3. You can only get 3 in multiplication by doing 3 times 1. 5's another one, 7's another one, 13's another one. In fact, the list is infinite. It goes on forever, but you can obviously pick out the small ones. The next definition that I want to go over are composite numbers. Now, composite number has the word composed in there, which means it's composed of more factors than just 1 and itself. So a perfect example there is 15. I gave you the one earlier of 20, but let's say I wanted to do 15. Let me get my pen up here. And I said 15. Well, how do I get 15? You can get 15 by doing 1 times 15, but you can also get it by doing 3 times 5. You could list 5 times 3 as well, but there's no point because the factors are still the same. You're just flipping them around. The commutative property, which we covered before, tells you that's the same thing. So there's no point in writing it twice. So that's an example of a composite number. Obviously, those are infinite as well. Next, I need to point out that 0 and 1 are neither prime nor composite. That's really important for you to understand. And then what I want to cover next is listing all of the factors for a number. So let's pick one, for example. I'm going to pick a number that has kind of a lot of factors. We're going to try the number 30. If I wanted you to list all of the factors for 30, what you do is you'd write down 30, and then you say, well, that is equal to, and you're going to put a little squiggly brace, and you're going to start with 1. 1 times the number. And what I want you to do is you're going to write 1 like this, and then you're going to write 30 off to the side and another squiggly. You're going to put a comma and a comma, and what we're doing is we're working our way in towards the center, so we're essentially bracketing our way in and getting rid of all other possibilities. Because one of the things that you might run into is you start writing factors down and you know, did I cover them all? Well, this is the way that you're gonna figure it out. So 1 goes in, 1 times 30 is one of them. Then you know 2 goes in there. 2 goes in, and 2 times what gives you 30? It's 15. And now I'm gonna put in my commas again. 3 goes in there, 3 times 10. Do you see what I mean by bracketing? Let me pull this pointer up here. These numbers are getting closer and closer together, and eventually we're going to run out of possibilities. That's what I mean by the bracketing. 4 does not go in there, but then 5 does go in, and it goes in 6 times. Now look what happened here. I just did 5 times 6. What's the next number after 5? It's 6. That's already listed, so I don't need to write it again, and I'm done. I covered all possibilities. So all I have to do is put in a comma like that, and I'm done. That will be listing all of the factors for 30. Okay, and again, use that bracketing method. Next, prime factorization. This is listing all the prime numbers that when multiplied together would give you the number that you're looking for. So the way that we're going to do that is we're going to use factor trees. I'm going to use the exact same example that I used before, 30. And what you're going to do is you're going to draw this little branches underneath there, and we're going to make our tree. Pick 2 numbers that multiply together to give you that 30. So I'm going to say 5 times 6. If you end up with one of those being a prime number, I want you to circle it. The other one is composite, so I'm going to break it down further. 6 you can get by doing 2 times 3. These are both prime numbers. Once you have all prime numbers, you're done. So you would just list them. So 30 is equal to 2 times 3 times 5. Now in math, we like to put those in order from the smallest one to the greatest. It doesn't matter. It wouldn't change the answer here, and we know that from our properties lesson as well, but it's just the way we like to see it. So put them in order. Now what I want to show you, this is kind of important. It doesn't matter what you start with, as long as you pick 2 factors that actually, when multiplied together, will give you 30. So if I started with 3 times 10, for example, instead of the 5 times 6, there's a prime number. I'm going to break this down then into 2 times 5. Now I'm all primes, write them in order, 2 times 3 times 5. And if you look, this is the same as that. It works. You end up with the same thing. As long as you pick 2 numbers initially that multiply together to give you that. So the prime factorization is prime numbers that are all multiplied together to give you that number. And that's what we have here. 2, 3, and 5 are all prime numbers. The way that you find it is by using factor trees. So prime factorization and factors are different things, and you don't want to get them confused. But remember that word prime there. It just means it's going to be all prime numbers. Okay? Let's move on. One of the things I think is very helpful for you to know are divisibility rules. Because when you try and find factors, prime factorization, it's helpful to know some divisibility rules. And I'm going to give you a few that I think are very helpful when working on these type of problems. So 2, I'm sure most of you know that one already. If it is an even number, then it's divisible by 2. So if it ends in a 0, 2, 4, 6, or 8, then that number is divisible by 2. 3, if you add up all of the digits and the sum is divisible by 3, then the number is divisible by 3 as well. So for an example, if I said whoops, I have my highlighter on still. Let me erase that. That's pretty funny. Okay, if I use the number 156, for example, I took these digits, 1 plus 5 plus 6. That's equal to 12. The number 12 is divisible by 3, so 156 is also divisible by 3. That's how you would use that rule. 4 is kind of handy, kind of not handy. So 4, the rules are if the last 2 digits are divisible by 4, then the number is. And if it ends in 0, 0, then it is. So how that's helpful? First of all, the last 2 digits, it's not necessarily helpful if you're talking about a large number like 96. 96, by the way, is divisible by 4, but you don't necessarily know that off the top of your head. But if you had a number like 148, you know that 48 is divisible by 4, so 148 is. And then if you have a number like 500, it ends in 2 zeros, that's divisible by 4. That's where I think it really is kind of handy. 5, if the last digit is a 5 or a 0, then it's divisible by 5. 6 is kind of cool. If it's divisible by 2 and by 3, then it's also divisible by 6. So in the example that I gave earlier, the 156, we figured out that that is divisible by 6 because the sum of the digits is 12. It ends in a 6, so it's divisible by 2. This number is also divisible by 6. Very cool. Don't have a good one for 7 or 8, but 9, there's a great one. It's just like 3. If you add up the digits and the sum is divisible by 9, then the number is also. And then everybody should know 10. 10 is beautiful. It ends in 0. It's divisible by 10. That's our quick divisibility. Now, knowing those, let's try and do some problems. So here I have 3 numbers. I have 18, 23, and 150. What I want you to do is say, are they prime or are they composite? If they're composite, write all the factors for the number and the prime factorization. Now, if you feel comfortable with this, go ahead and pause the video and try these yourself. If not, just follow along with me. I do have one I'm going to make you try though. So first, 18. Well, 18, it ends in an even number. So you know the 2 goes into it. Automatically you know that it's composite. So we'll say, all right, this is composite. And if I want to list all the factors for 18, I'll put my little squiggly. I have 1 times 18 comma, comma, 2 goes in 9 times, and then 3 also goes in, because remember the sum of the digits, goes in 6 times, 4 does not, 5 does not, 6 is already listed. I'm completely done. Then for the prime factorization, I'm going to make my little tree, pick 2 numbers. This is prime, break this down, prime, prime, and there's my prime factorization. So 18 is equal to 2 times 3 times 3. Now what you will see with some teachers, they like to write this, and by all means you could do this. You could take these numbers right here and you can combine them and put an exponent on it. So the way that you would do that is you would say 2 times 3, and then how many 3's are there? There are 2 of them. That would be your exponent. So 2 times 3 to the second power, and it's just condensing that. That's acceptable as well. It means the same thing. 23. 23 is a prime number, so there's nothing to do there. And then 150 is composite. Now 150 has a lot of factors. So if you want to try doing that one, try it. It's kind of cool. If not, just follow along. Is equal to, we're going to do 1. I'm going to go way out here, 150, because I'm going to need some serious space for this one. 2 goes into it because it ends in an even number. So 2 goes in 75 times. 3 goes in because of sum of the digits, so we know that works. 3 goes in 50 times. 4 does not go in. 5 goes into it because it ends in a 0. 5 goes in 30 times. 5, 30. 6, you know, is going to go into it because 2 and 3 go into it. So 6 goes in. You see how these things come in handy? That's why these divisibility rules are really nice. 6 then goes in 25 times. Hope I have enough room. 7 does not go in. 8 does not go in. 9 does not go in. And then 10 goes into it because it ends in a 0. 15 times. Whew. And I ran out of space, but that's okay because that's all I need. 11 doesn't go in, 12 doesn't go in, 13 doesn't go in, 14 doesn't go in, 15's already there. Ciao, I'm done. You can see that's a lot of space. Now for the prime factorization, this is actually kind of simple. It ends in a 0, so I'm going to use 10 right away. I think that's the easiest one, but all the factors are up here. You can use any of those. So I'm going to do 15 times 10. This is 3 times 5. Those are both prime, so I'll circle them. And then 10 is 2 times 5, and I'll circle those. My prime factorization for 150 is going to be 2. I'm putting these in order. Times 3 times 5 times 5. And again, you could write this as 2 times 3 times 5 to the second power. Okay? Now, this last page, I want you to pause the video now. You have to try this one yourself, okay? That means you too, Tommy. Try this one. So pause the video, try this, and then see if you get the correct answer. Because if not, you're going to have to go back and try it again. Pause. Okay, good. All right, welcome back. Hopefully you got the right answer. I'm just going to go ahead and write it out. All the factors for 60 and the prime factorization. So 60 for all the factors. There's a lot here as well. So I'm going to make sure I give myself plenty of space. 1 and 60. And I hope that's enough space. 2 goes in 30. And then 3 goes in 20. And then 4 goes in 15. It's getting a little small on space. And then 5 goes in 12 times. And I'm not going to have enough space. Am I going to? Yes, I am. And then 6 goes in 10 times. Whew, I fit them all in. Unbelievable. For the prime factorization, 60, just break it down. I'm going to do 10 times 6. I love doing 10. 10's a great one. 2 times 5 for 10. 6 is 2 times 3. So for my prime factorization, I have 2 2's, a 3, and a 5. And again, this could be written as 2 to the second power times 3 times 5. Hopefully you got that right. Now, don't forget to subscribe. Turn on those post notifications to get the next lesson. Take care, everybody, and I'll see you next time. Goodbye.